Hello class, this is Mrs. Moulton. We are going to be doing lesson 2-11 today. Let's start with the warm-up. Number 1 says, write an equation to represent the amount your investment is worth after T years. Okay, we have an investment of $120, earns 1.5%, compounded monthly. First thing we need to do is we need to decide what is P, what is R, and what is N. We know P is 120, that's our initial value. R is 1.5%, which is 0.015 as a decimal, and it's compounded monthly, so N is 12. Now we need to write our equation, which is going to be A equals, I'm going to try and do this off to the side here, 120 parenthesis 1 plus 0.015 divided by 12, and the whole thing to the power of 12t. Okay, now we're going to make a table, and the first number is 120, 5 is 129, 10 is 139, 15 is 150, 20 is 162, and 25 is 175, 30 is 188, and 35 is 203, and 40 is 219. Okay, now we want to graph it. Okay, so we know that the x-axis is going to be time, and then it's years, and the y-axis is going to be account balance, and that's going to be in dollars. So to graph it, we start off with 120. Then we go to 129, then 10 is 139, 15 is 150, 20 is 162, so we get that on there, 25 is 175, then 30 is 188, and 35 is 203, and then 40 is 219. And then we can connect those dots. Okay, the next one says an investment of $4,000 earns 3.25% and is compounded semi-annually. Write an equation to represent the amount the investment is worth after T years. So again, we're using our compound interest formula. So we have A equals 4,000, parenthesis 1 plus 0.0325, all divided by 2 because it's semi-annually, all to the power of 2t. Okay, how much is the investment worth after 25 years? Well, we're just going to take this 25 right here and plug it in for t. Don't forget, when you put that in the calculator, you have to have parentheses around 2 times 25, or you can just put in the calculator 50. And you get that the answer is approximately $8,955.46. Okay, number 5 reads, an investment of $10,000 earns 7.4% and is compounded daily. Write an equation to represent the amount the investment is worth after T years. So we have A equals 10,000, parenthesis 1 plus 0.075 7.4, all divided by, it's compounded daily, so there's 365 days in a year, to the power of 365t. So I want to know how much the investment is worth after 15 years. So I take that 15, plug it in for t. Don't forget to put parentheses around that. And I get approximately $30,340.17. Okay, we have now an investment of $10,000 that earns 7.4% and is compounded monthly. So our equation is A equals 10,000 parenthesis 0. Wait a minute, did I do that last one wrong? Hold on. Nope, just the same numbers. Had to check really quick. Sorry about that, guys. Okay, so we want to write this equation. So 0. Oh, just kidding. I forgot my 1 plus. 1 plus 0.074 divided by 12, and we get also to the 12t. Sorry about that. Now we want to figure out what it's going to be worth after 15 years. I take that 15 and I plug it in there for t. Don't forget to put parentheses around that in your calculator. And I get approximately $30,240.33. Okay, why are the answers from 6 and 8 different even though the percent and time are the same? Well, the reason being is because the one in number 6 is being compounded daily. The one in number 8 is being compounded monthly. And remember, the more you compound, the more money, the more interest you're going to accrue. I have that the percent and time are exactly the same. If I increase the amount that is compounded, that's going to give me more interest. So if I compound daily, I'm going to have more interest than if I compound monthly. Okay, Hannah has $2,600 in her savings account. She withdraws $150 every month. Let X represent the number of months and Y represent the account balance. I'm going to give you guys a minute to think about this. What is the slope and what is the y-intercept? Because I'm asking for the slope and y-intercept, we're going to be thinking about y equals mx plus b. We're going to be thinking about slope-intercept form. So take a minute and think about what is her y-intercept and what is her slope. Okay, since we have X as the number of months, we need to know what's happening every month. She is withdrawing $150 every month. So since she's withdrawing, that is a negative $150. And she begins with $2,600 in her account, so that's $2,600 is the y-intercept. Number 3 asks us now to write the equation. So our equation is going to be y equals negative 150x plus 2,600. Or we could write y equals 2,600 minus 150x. Okay, we now need to graph this. So we're going to start off with our x-axis, which is time. And we're going to make it months. Our y-axis is going to be the account balance. And that's in dollars. Since our y-intercept is $2,600, we're going to start there at $2,600. And then we go down 150 and then over 1, down 150 over 1. But I'm actually going to just do a little bit of shortcut here. I can see that I go from 2,600 down to 2,000, that's 600, and that's every 4 months. Okay, so I'm going to go ahead and just put a dot there. It's going to make it easier to connect. Then I'm going to do it again, down 600 over 4, over here to 8, down 600 over 4, then down 600 over 4. And if we're going to connect that line, we're going to go ahead, I'm going to attempt to do this. Connect this line right here. And there's a definite beginning and end there, so we don't want to have arrows on either end. Okay, the next one says the half-life of niobium 97 is 1 minute. An experiment started with 30 grams of niobium 97. So first of all, I want to know, what is my rate of growth or decay? If it's half-life, I know that it is decaying. So we want to know what is our rate of decay. And then we want to know what is our growth factor. So right here, we know that we have a half-life. And remember that we always said that if we have half-life, that B would always equal 1/2. And B is our growth factor. Oh, I am just sorry on that one. I should have crossed out decay there. Sorry, I should cross out growth and not decay. Okay, so we have that our decay factor is 1/2. Okay, and remember, how do I get that for my rate of decay? Remember, that's 1 minus R, which is 1/2. So our rate of decay is also 1/2 in this case. Our equation, if you think about that, everyone take a minute to write the equation. See what you think it's going to be. So our equation should be y equals, we started with 30 grams, our decay factor is 1/2 to the power of x. So that is our equation. Y equals 30 times 1/2 to the power of x. Okay, now let's fill in the table. And we're going to go ahead and say this is x and this is y. And let's just do the numbers. Let's look down what we have on the graph there. It goes from 0 to 8 on the graph. So let's go ahead and just do that. So we're going to go 0, 1, 2, 3, 4, 5, 6, 7, 8. And we know that 0 is 30. I'm going to give you a chance to fill this out now. Go ahead and fill it out and then graph the table. Okay, 1 is 15, 2 is 7.5, then this one is 3.75, 4 is 1 point, I'm just going to put 1.9, 5 is 0.9, 6 is 0.5, 7 is 0.2, and 8 is 0.1. Okay, let's graph it now. Okay, our x-axis is going to be time in minutes, and our y-axis will be number of grams. We start off with 30 grams, and then we go to 15 grams, then to 7.5 grams, then 3.75, about right there, and then 1.9, then 5 is going to be almost 1, then we just get smaller and smaller, so it's just going to be easier if I just graph it now at this point. Let's go ahead and connect our dots. Okay, our next problem. Okay, our next one is you invest $350 at 1.2% compounded quarterly. You want to write your equation and then find your value of your investment after 8 years. Okay, go ahead and do that. Okay, our equation should be A equals 350 parenthesis 1 plus 0.012 divided by, since it's compounded quarterly, we're dividing by 4 to the power of 4t. To find the value of our investment after 8 years, we take 8 and we plug it in for t. Don't forget to put parentheses around that when you put that in your calculator. Go ahead and try that. Okay, and your answer is approximately $385.21. Okay, number 13. A pendulum loses 12% of its height after every swing. The pendulum has a height of 2.7 centimeters after 22 swings. We want to find the initial height of the pendulum, and we want to round to the nearest whole centimeter. So go ahead and set that up. Okay, so we're going backwards here. I want to know what my initial height is. Oops, I need to grab that first. What our initial height is. So I know that it's 2.7 centimeters, and that equals A parenthesis. Then it's 1 minus 0.12 to the power of, this happens at 22 swings. This is one way to set it up. Then I want to simplify my 1 minus 0.12. So I have 2.7 equals A parenthesis 0.88 to the power of 22. So now let's simplify. We want to divide both sides by 0.88 to the power of 22. And our answer is about 45 centimeters. Okay, I'm going to do it the other way now. So the other way I could do this problem is y equals, I'm at 2.7, parenthesis, 1 minus 0.12 to the power of negative 22. Because I'm going backwards in time, 22 swings. So I can put my calculator, y equals 2.7, parenthesis, 0.88 to the power of negative 22, and you still get approximately 45 centimeters is where we started. Okay, our next problem, Jim is renting a car for $45. He must also pay 20 cents per mile that he drives. Let M represent the number of miles and Y represent the total cost to rent the car. So find the slope, the y-intercept, and then write your equation to represent the total cost where M is miles. Okay, our slope, it's 20 cents per mile, so that's 0.2. The y-intercept is what we start with, that's $45, so that's 45. So our equation is y equals 0.2 m plus 45. Question 17 asks, what does the slope represent? So go ahead and write down what you think the slope represents and what the y-intercept represents. And that's my dog barking. Okay, the slope. The slope means that Jim pays 20 cents per mile he drives. Jim pays 20 cents per mile he drives. The y-intercept means that Jim has to pay $45 initially just to rent the car. So Jim pays $45 to rent the car. Now we want to graph it. Our x-axis is going to be number of miles, and our y-axis is going to be the total cost. And that's in dollars. So we start off at 45, that's what the y-intercept is, and then we're going to go up 20 cents for every 1 mile, and if you notice down here, it goes every 5. And actually, so 5 times 20 cents is $1. So for every 5 miles, it goes up $1. Makes it nice and convenient for us. And we'll go ahead and connect those dots. And draw an arrow at the end. The last question, 20. If Jim had $200, how far can he drive the car? So I know that 200 is the total cost. So if he had $200, and that equals 0.2 m plus 45. So you need to solve that equation now. So we subtract 45 from both sides. I get 155 equals 0.2 m. Divide both sides by 0.2. And the number of miles is 775. That's how many miles he could drive on that car. Okay, on the back page, you invest $20 at 8.5% compounded daily. We want to write an equation to represent the value of your investment after T years. So go ahead and write that. You should have A equals 20 parenthesis 1 plus 0.085 all divided by 365 because it's compounded daily, and 365 times T. So that is your equation. Okay, we want to fill the table so that we can graph it. So this will be T and this will be capital A. And I'm going to go ahead and give you these numbers. Let's go with 0, 5, 10, 15, 20, 25, 30. And I just got those from the x-axis, looking what I had there. So go ahead and find out what those numbers are and then graph it. Okay, the numbers are 20, 31, 47, 72, 109, 167, and 256.